Hey guys, Mr. Backerberg here. In this video, we're going to look at identity and inverse matrices. So an identity matrix is a square matrix that has ones along its main diagonal and zeros everywhere else. So for example, if we were to look at a 2 by 2 identity matrix, we would have ones on this main diagonal and zeros in those other entries. Or if we were to look at a 3 by 3 identity matrix, then again, we would have ones along the main diagonal, but zeros as all of those other entries. And this pattern would continue for a 4 by 4 or a 5 by 5 or a 6 by 6 identity matrix. And one special property that an identity matrix has is when you're doing matrix multiplication, if we had some matrix A and we multiplied it by an identity matrix, then the answer we get back would just be that exact same A matrix that we started with. And I'm going to show you this on our calculator. So on our calculator, if we look right above that X with a -1 on the left-hand side, there's a matrix menu in there. So I'm going to hit second and that X with a -1 on it. I'm going to go over to edit and I'm going to edit matrix A. And I'm going to enter in a 3 by 3 matrix and I'm just going to go 1, 2, 3, 4, 5, 6, and 7, 8, 9. So we've got those entries in our A matrix. And I'm going to go back to my matrix menu because now I want to edit matrix B. And I'm going to enter in an identity matrix here. So ones along the main diagonal, but zeros everywhere else. So there's our 3 by 3 identity matrix. And I'm going to quit out of here. And then I'm going to take matrix A and I'm going to multiply it by that identity matrix that we just entered in matrix B. So we should notice that that answer we get back is the exact same matrix A that we entered initially. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you multiply a matrix by an identity matrix, you get back the same exact matrix that you started with. Now when we're talking about the inverse of a square matrix, let's say we have matrix A and it's an n by n square matrix. Then matrix B is its inverse if when we multiply them together in both orders, so taking A times B and B times A, we get an identity matrix as our answer. If that's the case, then we would say that B is the inverse of A, and we denote that with A with a -1 power on it, so that means the inverse of A. Or we could also say this A inverse. So here we've got two matrices, A with the entries 3, -2, -1, 1, and B with the entries 1, 2, 1, 3. And we're going to verify that they are inverses of each other by doing multiplication. So the first thing we're going to do is A times B, and we're hoping to get an identity matrix as our answer. The first thing we should check as we're doing the multiplication is the order. So these are each 2 by 2 matrices. And we notice those middle numbers match up when we're doing A times B. So this is going to work out. We will get a 2 by 2 matrix as our answer. So I'm going to start building that over here. So doing the row by column multiplication, I want to take the first row from matrix A times the first column from matrix B. So 3 times 1 plus -2 times 1, we're going to get 1 as our answer. That's the first row times the first column, so that answer goes in the first row, first column. Then I want to take the first row times the second column. So 3 times 2 plus -2 times 3. We get 0 as our answer there. So that goes in the first row, second column. Then I want to do the second row from matrix A times the first column from matrix B. So -1 times 1 plus 1 times 1. We get 0 as our answer. And then I need to take the second row from matrix A times the second column from matrix B. So we're taking -1 times 2 plus 1 times 3, and we get 1 as our answer. So when we did A times B, we got an identity matrix as our answer. But now we're going to do the multiplication in the other order. Now we're going to take B times A, and hopefully we'll get another identity matrix. So now I need to work with the rows from matrix B and the columns from matrix A. So I'm going to take the first row from matrix B times the first column from matrix A. So 1 times 3 plus 2 times negative 1. We end up getting 1 as our answer. Then I need to take the first row from B times the second column from A. So 1 times negative 2 plus 2 times 1, and we get 0 as our answer there. Then I move on to the second row from matrix B and the first column from matrix A. So 1 times 3 plus 3 times negative 1, and we get 0 as our answer. And then I've got one more set of multiplication to do. The second row from B times the second column from A. So 1 times negative 2 plus 3 times 1. We do get 1 as our answer. So when we did the multiplication in both orders, we got identity matrices each time. So that means that these matrices are inverses of each other. So we could say that B is the inverse of A, or we could say that A is the inverse of B. Now it is possible for us to find an inverse matrix using our calculator. So we've got this matrix A with entries 2, 3, negative 1, negative 1, 0, 4, and 0, 1, 1. And we're going to use our calculator to help us find its inverse. So I'm going to go second matrix, and I'm going to edit matrix A. We've got a 3 by 3 matrix that we're dealing with, but we're going to have to change the entries in here. So we've got 2, 3, negative 1, and then negative 1, 0, 4, and then 0, 1, 1. Now I'm going to quit out of here and go back to my main menu. I'm going to go second matrix. I'm going to grab matrix A, and then to find its inverse, we're going to hit that matrix button, but we're not going to hit second first. So we want to put that negative first power on that matrix A. So we hit enter, and our calculator will spit out an answer for us, and this matrix is the inverse of matrix A. So in this last example here, what we're going to do is show that a matrix has no inverse. So here we've got matrix A with entries 6, 3, 2, 1. And we're going to show that this matrix has no inverse. Now, one thing we said was that if we multiply a matrix by another matrix and get an identity matrix as our answer, then we know that those things are inverses of each other. So we're going to try to do that here with matrix A. But I'm going to need to introduce another matrix. So I'm going to call this matrix B. But the problem is we don't know what matrix B's entries are. So we're just going to enter in some general values. And I'm going to do X, Y, Z, and W. But now, if A and B are going to be inverses of each other, then when we multiply them together, it should give us an identity matrix. So we're going to try to do that. We're going to try to take A times B and somehow end up with an identity matrix as our answer. So in our identity matrix, because we're dealing with 2 by 2 matrices, we should have a 1, a 0, and then another 1. So what we're going to do is we're going to take the first row from matrix A times the first column from matrix B. So 6 times X is going to be 6X plus 3 times Z is 3Z. But then I'm going to take the first row from matrix A times the second column from matrix B. So 6 times Y is 6Y plus 3 times W is 3W. Then I'm going to take the second row from matrix A times the first column from matrix B. So 2 times X is 2X, and 1 times Z is 1Z. And then lastly, I need to take the second row from matrix A times the second column from matrix B. So 2 times Y is 2Y, and 1 times W is 1W. Now, in order for these matrices to be inverses of each other, then as we're building this new matrix here, then it's supposed to equal that 2 by 2 identity matrix. So I can actually take the pieces of these matrices and build some equations. And I'm going to focus on the first column. So we've got that 6x plus 3z from that matrix on the left, and with that 2 by 2 matrix on the right-hand side, we've got a 1 as that entry. So this stuff should equal 1. And then if I look at that second row entry, we've got the 2x plus z, and that's supposed to equal 0. Now we're going to try to solve this system of equations to figure out what our x and our z values should be. And I'm going to do this using elimination. And I'm going to focus on the x's. So with that top equation, we've got 6x's. So in order to cancel that out, we would need negative 6x's. So I'm going to take this second equation here and multiply by negative 3. So that should give me negative 6x minus 3z equals 0. And when we add these together, we'll notice that the x's cancel out and the z's cancel out. So we're getting 0 on the left-hand side. But when we add up the right-hand side, we get 1. So this should tell us that there are no solutions. And because there's no solutions, then we're not able to figure out what our x and our z values are, meaning that there is no inverse for this matrix A that we started with at the beginning. That's going to be it for this video. Thanks for watching.